In this video, we're going to be engraving glass with a blue diode laser. Now, most of you have probably seen this done before to varying degrees of success, and it's certainly possible with the use of some kind of laser marking paper, paint, or other coating, and that's because normally the blue diode laser would pass right through the glass if it wasn't for some kind of coating on the surface for the blue laser to interact with. Now, in this video, we're going to be using several of these different types of coatings, and I'm going to be giving you guys the pros and cons of each. However, what if I told you that not all glass is made the same? And some of you may already know this, but this is not something that I see commonly talked about in other glass engraving videos on YouTube. So similar to there being different species of wood, with the various types of glass, we're going to need different power and speed settings for our laser engraving process, and that's what we're going to explore in this video. I spent quite a bit of time running various tests and sourcing different glass materials to work with, so I want to share with you guys my successes and failures. So let's get started.
We'll begin with soda lime glasses, and this is probably the cheapest and most plentiful type of glass out there. Everything from those really inexpensive picture frames to these very common glass jar containers. And to mark this glass, I'll be using a few different types of coatings. The first one being this laser marking paper. And if you haven't worked with this stuff before, it's super easy. You just dunk it in some water, peel it off, and then apply it to your glass. And you can smooth it out with a squeegee or even something soft like a cloth. And this stuff is really thin and you don't want to tear it, so don't try and smooth it out too aggressively with anything too sharp. In those previous video clips, I demonstrated on a different piece of glass, but as you can see on this cheap glass picture frame, I'm just laying it on there and I'll smooth it out after. One of the other things I'm going to experiment with is this glass marker, as well as this Pentel wet erase chalk marker. The chalk marker is something that I've seen quite a few other people recommend, whereas the glass marker I think is more of like a dry erase marker. I just found it at my local craft store and I figured I'd give it a try. Now with both of these markers, you're going to want to remove them from the package, give them a good shake, and press on that chisel tip. This is going to get the ink or paint inside to begin to flow down into the chisel tip, and with a little bit of patience, you'll begin to see it drizzle down. Eventually, that felt tip applicator is ready to go, and you can just start to draw on some thick, bold lines. Try and get the application as even and uniform as possible. As you'll see throughout the video, an even application is absolutely key to getting nice, consistent results with the engraving. I'm going to be applying both the Pentel chalk marker as well as the glass marker to the picture frame glass as well as these generic glass containers. And just in case it's a little difficult to tell the difference between those two coatings on camera, I've gone ahead and labeled the two areas with a Sharpie. Here you can see all three coatings under different lighting conditions, some looking much more uniform than others. And we're going to be using the blue laser of the xTool F1 Ultra to do all of our engraving in this video. And we'll start off with the laser marking paper. So I've set the focus to the top of that paper, and then in xTool Creative Space, we're going to go ahead and make a material test array. I've made my first square shape, and I've set those base engraving settings to 60% power, 200 millimeters per second, and 200 lines per centimeter. But within the material test array, we'll try obviously a larger range here. So the max we're going to go up to is 85% power, the minimum is 45% power, the max speed is 250 millimeters per second, whereas the minimum speed is 100 millimeters per second, and we'll see how this works out for us. And this is a pretty broad range, and the reason I selected such a big range is because I haven't worked with a lot of this type of glass in the past. In previous videos, I worked a lot more with crystal glass, so I'm not really sure how this is going to work out for me, although I do suspect that some of those higher power settings might not be so great. And as you can see here, my hypothesis was correct, as the higher power settings with the slower speeds cause this glass to crack. Soda lime glass is not very heat resistant, and if you overdo it with your power and speed settings, you're going to find that the glass is susceptible to cracking and splitting. And so we have a couple options. One of them is to speed up our laser, the other is to decrease our power settings, or the third option is to also reduce our lines per centimeter. Reducing the lines per centimeter may not be the most obvious thing at first, but essentially what you're doing is reducing the amount of heat buildup in such a small localized area. And so for the second test, I've reduced the lines per centimeter to 160 And now I'm going to change the material test array to a maximum power of 65%, minimum 45%, increase the max speed to 260 millimeters per second with the slowest at only 180 millimeters per second. I'll be running this test on the glass marker, and you can see that the results aren't so great. And I think that has a lot to do with the fact that this coating is not very uniform and it's not very opaque. So we'll move on to the Pentel chalk marker, and for this one we're going to adjust the settings again slightly. So the base setting 60% power, the speed at 220, and I'll further reduce the lines per centimeter to 140. Now for the material test array, we'll stick with 65% max power, min 45%. We'll increase the max speed to 270 millimeters per second, and we'll increase the minimum speed to 200 millimeters per second. And although we're running different material test arrays on the different coatings on this glass, I feel pretty confident that we're zeroing in on some settings that are more usable. Inspecting this test array, things are looking slightly better, although I do notice that these surfaces are still cracking and peeling quite a bit. Now remember, this is really low quality glass. It's not at all heat resistant and it's very thin, but I think we've got some lessons learned here that we can now apply to these glass jars. And these glass jars are quite a bit thicker than that cheap picture frame glass, so I'm not concerned that I'm going to completely shatter it or crack it. But remember, what we're trying to do here is create small micro fractures on the surface without creating big shards coming off of this glass jar. So on this first test with the glass jar, I'm going to move back to the laser marking paper and I'm going to stick with that 45 to 65% power range, but I'm going to increase the fastest speed setting to 300 millimeters per second, and we'll see how this turns out. And this is looking a lot better. There's a lot less cracking of the surface of the glass, and things are looking quite a bit more frosted. Now the thing I love about the laser marking paper is that it is completely uniform, and this is going to be a big advantage of using this kind of coating. So none of those little test squares on the laser marking paper looked streaky or striped. I'm going to run a similar test on the glass marker, but this time my power range is only going to go from 45% to 55%, and the slowest speed in that material test array was 225 millimeters per second. I'm still working at 140 lines per centimeter, and in this case, because again of the unevenness of this application, I do not like the results at all. And I'm starting to actually give up on this glass marker, and I really don't think it's worth pursuing any further because of how uneven it is. Now running the exact same test on the Pentel chalk marker looks quite a bit better, although there are some areas that do look a little streaky. And that's because even with this chalk marker, although the chalk marker itself is more opaque, it's still hard to get a perfectly even coating on there. Looking at the results of those two material test arrays of the chalk marker and the laser marking paper under some better light, we can start to make some conclusions on perhaps what are the best settings to go ahead with and try out some graphics. I think for both coatings, 50% power is going to be the most appropriate power setting. I'll stick with the 140 lines per centimeter, and then I'll add a couple shapes and text inside of xTool Creative Space and vary the speeds on those things a little bit just to see if we can get some different results. So I'll go with 50% power, 320 millimeters per second at 140 lines per centimeter, and I'll just engrave this simple owl graphic on top of the laser marking paper. In a moment, we'll remove the laser marking paper and take a look, but the preliminary results are looking pretty good. Moving back to the chalk marker, we're going to run a similar test with the same owl graphic, but we're going to increase the speed significantly. So the power is going to remain at 50%. The speed we're going to bump up to 500 millimeters per second. And I've also added a little bit of text here. So the text, I'm going to bump up the top one to 525 millimeters per second and the bottom text down to 475 millimeters per second. So we get a small range, but ultimately with the chalk marker, I felt that I really needed to increase that speed to mitigate the risk of the surface of the glass chipping away. Now in some areas I felt like the graphic was slightly under processed, and in other areas you can still see that there was a little bit of chipping. And you'll probably hear me talk about this about 20 more times in this video, but it really comes down to how uniform you can get that coating. After washing the chalk marker under some warm water, I think this becomes even more obvious, and you can see how streaky that graphic is. I really don't like this result at all, And if you haven't worked with one of these markers before, you may be wondering why I didn't apply a second coat to try and get a thicker, more even application of this stuff. And that's because as you apply a second coat, it pushes away the first coat because I think it's water-based. So it's just gonna rub off the first coat. You can't really build it up. Now with the laser marking paper, the results were a lot better and I didn't have any chipping of the surface. You may also notice that I went back and added some text so you can get an idea of what that looks like, but it's a lot more uniform. And you can see the laser marking paper actually doesn't give you a frosted white look, it's more dark gray. And so the conclusion that I came to with this really cheap soda lime glass is that I would recommend using laser marking paper. Take extra special care to get that as uniform of an application as possible and really limit the heat buildup on this kind of glass because it fractures so easily. And finally, if I come across this glass again in the future, I may even try an even lower lines per centimeter setting of 100 to 120. Next up, we've got tempered glass, and it's intended for slightly tougher applications. It's like a type of safety glass that when broken, it shatters into smaller, blunt pieces that shouldn't cut you. You'll likely find it on things like glass doors, such as on microwaves, washing machines, or even on sunroofs of cars, or even a glass tabletop surface. And for this example, I sourced a glass cutting board that is certainly made of tempered glass. And I'm gonna be using the laser marking paper again, as well as the Pentel chalk marker. I've taken extra special care to apply both of these coatings as evenly as possible, and based on what I've seen online, the tempered glass should be tougher and more heat resistant, and so I've gone back to a broader range of power settings inside of my material test array. So a minimum power of 40%, a maximum power of 90%, and a speed range all the way down to 60 millimeters per second and up to 240 millimeters per second. All of this is being performed at 200 lines per centimeter, and we'll go ahead and put this under the xTool F1 Ultra and see what happens. And to my disappointment, it's looking like my initial estimates were quite a bit off. And it's weird because I did base these on quite a few other videos and posts that I've seen online of people doing a similar test on tempered glass with various other coatings, not laser marking paper, but I figured with a similar 20-watt laser, I should get pretty similar results, but that doesn't seem to be the case. Most of those little test squares were severely over-processed and also starting to chip away. So we'll move on to the chalk marker with some lessons learned, and we're going to reduce our power settings quite a bit and increase our speed for this test. Additionally, despite what I've seen other people do online, I'm really thinking that the 200 lines per centimeter is much too aggressive for even tempered glass. Therefore, in this next example, I'm going to reduce the lines per centimeter down to 160, and we'll create a new material test array. And this time we'll go with a max power setting of 70%, a minimum back down to 40%, a maximum speed of 250 millimeters per second, and a minimum speed of 170 millimeters per second. And remember that this is with a base setting of the lines per centimeter at 160. So that will get applied to all of those squares when we make this material test array within xTool Creative Space. And while this job is running, if you're wondering why I haven't been testing any aerosol sprays, that's because I'm trying to find a coating here that I can apply without any sort of ventilation indoors, and that produces very little mess. But unfortunately, so far I haven't been all that impressed with this chalk marker, despite the results that I've seen other people have online with it. And again, because of how difficult it is to get a uniform application of this, you'll see in the top left-hand corner of the material test array, with the fastest speed and the lowest power, I was still getting some chipping, and that's because the laser is being absorbed differently with areas of the paint that are thicker and thinner. Regardless, I think I can zero in on at least some reasonable settings that will get you guys into a good starting place if you're trying to use either of these coatings. So on the left-hand side with the laser marking paper, I've got two graphics there. I'll be using 50% power and 250 millimeters per second speed. With the pig graphic on the left, it's 160 lines per centimeter. With the butterfly, it's 120 lines per centimeter. And then with the Pentel chalk marker, we've got the monkey and the fox. And those will have the same power and speed settings of 50% power, 250 millimeters per second, and the same spread of the lines per centimeter, with the graphic on the left having 160 lines per centimeter and the one on the right 120 lines per centimeter. And looking at these results before cleaning the two coatings off, you can definitely see that the clear winner here is going to be the laser marking paper. Both of those, despite the two differences in the lines per centimeter settings, are looking much more uniform than the results on the Pentel chalk marker. As with the squares on the material test array, these two graphics are looking a little streaky, and for whatever reason, the edges of those graphics end up getting chipped and they peel off. Now, sometimes it's easier before even washing away those coatings to look at the results from the back side of the glass, and that tells us even more information. And in this case, it just confirms the initial findings where the laser marking paper is looking quite a bit more uniform. But regardless, we're still going to wash this stuff away and take a closer look. Now, looking at these engravings after washing away those coatings, I was surprised to find that the chalk marker didn't look as bad as I had originally thought, at least at 120 lines per centimeter on that Fox graphic. At 160 on that Monkey, it was just too aggressive. And the other thing I noticed is that the chalk marker produced a slightly more white and bright engraving, whereas the black laser marking paper again produced a graphic that was a darker gray color. The glass under the laser marking paper also seems to be less sensitive to the lines per centimeter, as both 160 and 120 looked perfectly fine. On the tempered glass, I also want to introduce a third coating option, which is tempera paint, and I see this recommended a lot online, tons of YouTube videos, Reddit posts, etc., and it's another water-based paint. It produces a really matte black surface when dry, and I'm going to water it down in the hopes that when I roll it on with a roller, it's going to self-level and we'll get a nice even application. But after a few tries, I'm realizing that this is just impossible and it's not the case. Similar to the chalk marker and other water-based paints and coatings, the first coat never adheres strong enough even after it's completely dry, that as soon as you apply a second coat, the water inside of the paint seems to wash away the first coating and you can't build it up. Now, if you're using something like an airbrush to apply this kind of paint, you won't have this problem and you can likely build up the tempera paint on the glass for a nice even coating, and it will probably work very well for you. But as I mentioned earlier, I'm really trying to find a solution here that doesn't require you to spray anything on and cause any of that paint to go airborne, because I want to find something that I can easily use inside without any sort of ventilation. But honestly, no matter what I tried with this paint, whether it was a roller brush, a foam brush, or a bristle brush, and trying different thicknesses of the paint, whether it's the paint itself or diluted with water, I couldn't get to a result that was perfectly uniform. That being said, the best result that I could find was with the foam brush and just slathering that paint on in hopes that it's going to be uniform enough that we can just run with it for this example and see what happens. So I've gone ahead and done that, and we're going to run this test at 120 lines per centimeter for the base of this material test array. And I've got a power range of 40 to 65% and a speed range of 200 to 360 millimeters per second. In this case, you'll also see that I've tried to laser on top of the glass, so the same side of the coating, and the results were, as I expected, a little bit streaky. Looking at the glass from the other side, you can see the results look slightly better, so it gives me some hope that when the paint washes away, it's not going to look too bad, but I still don't think it's perfectly uniform. Now, I've seen guys flip the glass over and try and engrave through the glass on the bottom side, and that's because if you can imagine that the bottom side of the glass has an even coating, whereas the top side you're engraving through different thicknesses. So we'll give this a shot, and the only thing I changed was that I lowered the focus into the glass so that ideally it's hitting the first layer of paint on the other side of the glass. I thought this was going to be a clever trick, but honestly, I don't think the results were even as good as the other material test array where I was focused on the top side of the glass. Even if it did work, I'm not really crazy about this method, and the reason for that is that if you can imagine that you're trying to engrave a glass jar or even a drinking glass, you don't really have access to the other side of the glass because it's obstructed because something like a drinking glass or a jar is round. So that method is pretty limited to flat pieces of glass, and for that reason, I don't think it's going to be a universal solution, but just for fun, we'll run another test where we'll engrave a dolphin on the top side of the glass. Again, this is with the coating facing up. In this case, 55% power, 300 millimeters per second, and 120 lines per centimeter. Then we'll flip the glass over and try engraving through the glass again. I've selected a different dolphin graphic, but we'll keep the same power and speed settings. So we'll select 55% power, 300 millimeters per second, and 120 lines per centimeter. If you recall, just a few moments ago with the laser marking paper and the Pentel chalk marker, I was using 50% power, 250 millimeters per second at a slightly higher lines per centimeter, around 140. And so despite these being similar black coatings, I'm finding that the power and speed settings need to be adjusted a little bit for the tempera paint. And upon initial inspection, neither of these engravings look all that great in my opinion. The dolphin that was engraved with the paint side facing up looked particularly streaky before the coating was removed, but after washing off the tempera paint with some warm water, it was the engraving with the paint side facing up that actually looked better. Now, did it look great? I would say no, but I think if you're willing to invest in an airbrush, you could get pretty decent results with the tempera paint. Next up, we've got Borosilicate Glass, and this should be the toughest type of glass that at least I'm dealing with in this video. And I've got this old 3D printer glass print bed. Now the one side does have this black screen-like print on it, but the other side is just bare glass. Now with Borosilicate Glass, you'll find it commonly on things like oven cookware, glass baking dishes, perhaps even lab equipment, or high-end water bottles. It's pretty resistant to thermal shock. And I'm going to set up this glass panel the same way inside of the F1 Ultra that I did with all of the other examples. And you can see that I've applied a small section of the laser marking paper as well as painted on a small section of the Pentel chalk marker. I'm going to run a test grid with the laser marking paper at a minimum power setting of 40%, maximum power setting of 65%, and the max speed 320 millimeters per second, minimum speed 200 millimeters per second, and this entire test array is going to be engraved at 120 lines per centimeter. Having read that this type of glass is more resistant to thermal shock, I was suspecting that it might be more difficult to engrave and perhaps I'd have to try higher power settings. However, I was very pleased to find that this so far was the easiest and best and most consistent type of glass to be engraved. You can see all of those test squares are looking extremely uniform and none of them have any sort of chipping. This is the kind of result that I was really hoping for with all of the other types of glass, and so I went ahead and ran the exact same test with the Pentel chalk marker. And the results here were reasonably good, although I did notice that at the lower power settings with the chalk marker that the squares were looking a little underprocessed compared to the laser marking paper. However, there was still a very good section of that material test array that was definitely workable. Now, unfortunately, because the other side of that glass has that coating on it, I can't view or show you on camera what the back side of the engraving looks like through the other side of the glass. Nevertheless, the engravings look good from the front, and I feel like we can zero in on some settings, so we'll go ahead and just produce a few small graphics. I've selected these very simple pig and monkey vectors right from within xTool Creative Space, and I'm just going to set them up with some very minor differences between each of those. Each of these vector shapes will be engraved at 120 lines per centimeter, and on the laser marking paper on the left hand side, the pig will get set to 50% power at 250 millimeters per second, whereas the monkey will get set to 55% power at 250 millimeters per second. So only a 5% difference in power, and I can do the same thing with the two vector shapes on the Pentel chalk marker. So the monkey on the left hand side for that one will be 50% power, 250 millimeters per second, and the other graphic will be 55% power, again 250 millimeters per second, and we'll see if we notice any sort of measurable difference. In terms of uniformity, I suspect we'll see what we've seen on all of the other examples where the laser marking paper looks quite a bit more uniform and consistent, and that's just because of the thickness of the coating, whereas on the Pentel chalk marker you're going to see more streaks. And that's exactly what I've found, especially before rinsing off the coating, and then after rinsing off each of those coatings, not much changed, where the laser marking paper produced a darker, more consistent result, and you can see with the chalk marker on the right hand side, it's a lighter result, which looks pretty good, especially against that black coating that's on the other side of this 3D printer print bed. However, what I did notice after washing off the chalk marker was that it was still susceptible to a little bit of chipping around the edges of each of those designs. And this just wasn't obvious until I washed that chalk marker off. Next, we'll be working with some crystal glass, and from what I've read, it is the addition of lead oxide inside of the glass that gives it its unique properties. Now, I've also read that there is lead-free crystal glass So I'm not sure if that will react to laser engraving differently, but either way, crystal glass is often used on things like fancy drinkware, trophies, awards, candlesticks, and other decorative pieces. It tends to have a nice heavy feel to it, and it refracts light very well. So if you engrave something on there and you light it up with some LEDs, it's going to look really cool. In one of my previous videos, I demonstrated this with one of these crystal glass awards, and on my website, I even have one of these fixtures to hold these specific awards inside of the xTool F1 as well as the F1 Ultra. In that previous video, I also demonstrated the engraving of this crystal glass award with the laser marking paper. And for that video, I had to sacrifice one or two of these crystal trophies in order to run a bunch of tests to get into the ballpark of what would be the optimal settings for this crystal glass. And in that video, I was mainly using the laser marking paper. So what I had found was that the settings that were best for me were 50% power, 225 millimeters per second speed, and 140 lines per centimeter. Now, unlike the borosilicate glass, I did find that crystal glass was also prone to chipping and cracking, so you won't want to overdo it with the power settings, and you'll also want to keep those lines per centimeter slow to avoid the surface of the glass peeling and cracking. Now, one other thing about crystal glass is that if you do plan on lighting up your design with some LEDs, I find that it looks better to view the engraving through the glass. And so if your design is directional, for example, if it has text, you'll want to flip your image horizontally before you engrave it. Therefore, when viewing it through the glass on the backside, the text would of course go in the right direction and you would be able to read it and it wouldn't look reflected. And while we're watching this engraving process go down, I would like to bring up the fact that during all of these video clips, I do have the protective cover of the F1 Ultra in the upwards position. I would not recommend doing it this way, hopefully for obvious reasons, especially considering that a lot of the materials that we're working with in this video are reflective. If your workpiece doesn't fit inside of the machine with the lid closed, I would definitely recommend wearing some laser safety glasses. I've got some on my website that attenuate both blue and IR lasers in a single pair, so this is very convenient when you're working with a machine like the F1 Ultra and you don't have to change your glasses when you switch between the blue and IR laser. And as I've gone off on this slight tangent about safety, you can see the results from the previous video where I engraved this crystal glass trophy with the black laser marking paper. And one of the things that I want to point out is that, as with other examples with the black laser marking paper, the engraving on the front side looks slightly dark gray. And that's one of the other reasons why I prefer to view the engraving through the glass, because the backside looks like a more frosted white. And I'll show you a close-up of that here so you can see that we were looking through the glass, and now at this point here I've got it flipped around where you can see some of the remnants of the black laser marking paper still on there that you'd have to really aggressively scrub to get off, but again, if you flip it around you don't see that at all. To light up these crystal trophies, we're going to be using the same RGB LED module that I showed you in the previous project example, and I'm also going to reuse the 3D printed trophy base with the brass engraved nameplate. As an alternative to the RGB lights, I personally think a warm LED light is the best choice for these crystal glass trophies. Now, this is just personal preference, but I think it has a very classy look to it and you can't go wrong. I'll put links to those warm LED light modules in the video description down below as well. In a moment, we'll be moving on to engraving some crystal whiskey glasses, and for that, I'll be holding them inside of a fixture sized for the xTool F1. However, as you may have noticed in this video, we've been using the xTool F1 Ultra. When using F1 Ultra, you'll see that I have these F1 to F1 Ultra fixture adapters that allow me to use regular size F1 fixtures on the Ultra base plate, and I can put one in the center or create a 2x2 grid pattern for batch processing. I get a lot of questions about these parts, so I figured I would just explain them once ahead of time instead of each and every time I use them. With that out of the way, let's talk about the crystal whiskey glasses, and I'll cut right to the chase. So I didn't have any luck personally with the chalk marker on these crystal glasses. No matter what I tried, I was experiencing a lot of chipping and cracking with that Pentel chalk marker, and really the only coating that I could work with was the laser marking paper. That being said, let's run through an example with the laser marking paper and my whiskey glass fixture. It's similar to a V-block fixture, but it's adjustable and it comes with two different tabs. So the first one is that small one. So if you have a cylindrical glass, you can set it up and the top surface of the glass is going to be parallel with the work surface. But if you have a tapered glass, you can use the taller tab and you can adjust it in and out on those slots. And that's going to push the base of the glass up or down so that the top surface that you want to engrave on is parallel with the work surface. I can check to see if my glass is level with the RA2 bubble level holder, which you can also find on my website. And it looks close enough, so it seems like we've got this thing set up properly. And you may have also noticed that this glass is not perfectly cylindrical. The base of the glass almost tapers down to a rectangular shape, but the V-shaped fixture still holds it in the center perfectly. And I really like these particular glasses because they're very heavy. The package says that they're made from real crystal glass, and they're very pleasing to hold because of that unique shape. Of course, I'll put a link to those in the video description down below so you can find these exact whiskey glasses. Now for the settings, not surprisingly, I'll be using the same settings as I did with the crystal trophies, and that would be 50% power, 225 millimeters per second at 140 lines per centimeter. I mentioned a moment ago that I didn't really have any luck with the chalk ink marker. However, if you are going to try something like tempera paint, I would recommend airbrushing it on. I get the sense that crystal glass is even more sensitive to having a very uniform and even coating on the surface. Even with the laser marking paper, you need to be very careful that you're not capturing any air bubbles under the paper and that you force out all of the water and moisture under the paper during the application process. There's a pretty direct link between the level of care that you put into preparing your workpiece to the quality of the engraving that you get out of it. And this general rule seems to apply to not only the crystal glasses, but all of the other materials that we've used in this video. And I think that should be the biggest takeaway from all of the experiments in this video. The power and speed settings that I shared with you should give you a good starting point for the various materials. And if you don't want to work with aerosols or spray-on applications, then I would say that the laser marking paper is the best and easiest material to work with. I'll link to some of that in the video description down below. I will be honest though, depending on the complexity of the design, the laser marking paper will be more tedious to remove than perhaps washing off or wiping away a water-based paint coating. I'll be publishing a quick reference guide with all of the information in this video on my website, so you'll find a link to that in the video description down below. If you guys found this video helpful and informative, please consider subscribing to my channel and visiting my website, embracemaking.com. On my site, I've got a lot of great tools and accessories for laser enthusiasts, so please go check that out. Thanks for watching and see you guys in the next video.